Hi everybody, today we're going to take a look at part one of 3 parts for partial fractions. This is section 9.4. This tends to be one of the more difficult sections for this week's assignment. So let's take a look at the handout I gave you a couple days ago over partial fractions. Okay, so let me share it with you. Okay, so we're going to do partial fractions. So what in the world is partial fractions? Well, let's take a look at how we actually do add rational fractions together, right? Rational expressions together, or subtract if there's a subtraction between them. The first thing we need to do is we need to find the common denominator. Okay? So if we start out with 4 over x plus 3 plus 2 over x minus 2, I would multiply the x plus 3 by x minus 2, which means I have to multiply the 4 by x minus 2. That gives us this 4 times the quantity x minus 2. I'd have to multiply the x minus 2 down here by x plus 3. So that means I have to multiply the 2 by x plus 3. So that gives us in the top here the quantity 2 times the quantity x plus 3. And then we simplify and combine like terms. We get 6x minus 2. Multiply out the bottom, we get x squared plus x minus 6. That would be our final answer. If we were in Algebra 1 or 2, that would be it. That would be what we would do. We'd circle that up and call it a day. Okay, here's what we're going to do. We're going to take this final version and we're going to work our way backward. Now, there are 3 main scenarios. That's why we have 3 videos. There's the non-repeated linear factors in the denominator. There's repeated linear factors in the denominator. And then there's irreducible quadratic forms. Okay, so we're going to go over all 3 of those different scenarios. For this video, we're going to look at the non-repeating linear factors in the denominator. So by non-repeating linear factors, I mean exactly this, like this x plus 3. X plus 3 is a linear factor because it fits a form mx plus b, and it's not repeated. There's no x plus 3 quantity squared. And the same thing is true with the x minus 2. So this is the procedure that we would do for non-repeating linear factors. We're going to start out with 7x minus 4 over x squared minus 2x minus 8. So the first thing we're going to do is we're going to factor the denominator if we need to. So in this case, we factored the x squared minus 2x minus 8 as x minus 4 and x plus 2. Now, here's where we do the decomposition part. Okay? In step 2, we set it up. So when we have non-repeating linear factors, how do we set it up? Well, whoops, that's a little too far. Sorry about that. We set it up as a over one of the factors. In this case, I chose the x minus 4, plus b over the other factor, x plus 2. Now, the common denominator is x minus 4 and x plus 2, this factored version of it. If I look at the x minus 4, I would have to multiply it by x plus 2 to get the common denominator, which means I have to multiply the a by x plus 2. That's where this part came in. For x plus 2 in the denominator, I'd have to multiply it by the x minus 4. So that means I have to multiply the b by x minus 4. That's where this part came in. These 2 things, when I simplify, distribute, and combine, have to add up to be 7x minus 4, the numerator of the original. So that means when I simplify, distribute the a, get ax plus 2a, distribute the b and get bx minus 4b. That has to add up to 7x minus 4. And that means that since 7x comes from the ax plus bx, that means a plus b have to equal 7, the coefficient there. And also, the minus 4 comes from the 2 constant terms, 2a minus 4b. So 2a minus 4b equals negative 4. This sets up a system of equations for us. How we solve that system of equations is totally up to us. We could do elimination. We could do substitution. We could do that RREF thing that we learned on our calculator. Either way, we end up with x equal 4 and y equal 3. So the 7x minus 4 over x minus 4 plus times the quantity x plus 2 is equivalent to 4 over x minus 4 plus 3 over x plus 2. Now, a lot of people say, why would you want to do that? Because sometimes taking this more complicated rational expression and breaking it down into less complicated rational expressions makes some process we're doing more straightforward. Okay? Like in calculus, an idea called integration. If we can integrate each one of these broken down terms, fractions, if you will, then it makes the integration a little bit more straightforward. And you're going to see a lot of this if you take Calc 2. So in our second example, we have 3x squared minus 17x minus 20 over x to the third plus 3x squared minus 10x. So here, we'll factor the denominator by first factoring out the common factor of x, leaving us with x squared plus 3x minus 10. And then factoring x squared plus 3x minus 10 into x minus 2 and x plus 5. So our denominator has x minus 2, and has x plus 5. Each one of those is a linear factor, and none of them are repeated. So when we have three non-repeated linear factors, we take a over one of them, plus b over the second one, plus c over the third. If we had a fourth one, we'd have d over the fourth one, and we just keep that trend continuing. Okay? So now we're going to do the same process. How do we get the 3x squared minus 17x minus 20? Well, let's look and see what we have to multiply this x by. We'd have to multiply this x by x minus 2 and x plus 5. So that means the a has to be multiplied by x minus 2 and x plus 5. So it gets a little bit more messy. What do we have to multiply the x minus 2 by? Well, we'd have to multiply by x, and we'd have to multiply by x plus 5. So that means b has to be multiplied by x and x plus 5. And then what about the c? Well, we have x plus 5 in the denominator there, which means we have to multiply by the x and by x minus 2. So that's where this cx times the quantity x minus 2 comes from here. Distributing, we get ax squared plus 3ax minus 10a after we multiply the x minus 2 and the x plus 5 together. Distributing the bx, we get bx squared plus 5bx. And distributing the cx, we get cx squared minus 2cx. Now, since these x squared terms, the ax squared, the bx squared, and the cx squared have to add up to 3x squared, ax squared plus bx squared plus cx squared gives us that 3x squared. So a plus b plus c have to be 3. So that's where that came from. When I look at 3ax, the 5bx, and the minus 2cx, all of that has to add up to minus 17x. And so that's where this 3a plus 5b minus 2c comes from. And then all that's left with the 10, with the constant of minus 20 is this minus 10a. And so that means minus 10a has to equal minus 20. And so that means that we could substitute, we could divide out by minus 10 and get a equal 2, plug it in here and use a 2 by 2 scenario, do more substitution. We can solve this any way we want. And we can solve it with the calculator even. Either way, we get a equals 2, b equals minus 3, and c equals 4. So that means we get 2 over x minus 3 over x minus 2 plus 4 over x plus 5. Next time, we're going to talk about what we do with repeated linear factors. Until then, take care. Hopefully this helps you.